Welcome back students to another lecture of chapter 15 probability of maths. In the last lecture we studied what is probability, the formula for finding the probability, and we saw that the probability of impossible event is 0 and the probability of certain event is 1. And the probability of any event will always lie between 0 and 1. And sum of probabilities of all possible events of an experiment is 1. And we solved the examples related to probability. Now in this lecture we will solve some more examples related to probability. So let us start with the examples. 1500 families with 2 children were selected randomly and following data was recorded. Compute the probability of family chosen at random having 2 girls, 1 girl and no girl. So here total number of families are 1500, that is total number of trials is 1500. Now first we have to find the probability that a family chosen at random is having 2 girls. So now in the table you can see that there are 475 families who are having 2 girls. So let E be the event that a family selected randomly is having 2 girls. So probability of event E is equal to number of families having 2 girls upon total number of families, that is equal to 475 upon 1500, which is equal to 0.3167. Now second is we have to find the probability that a family selected at random is having 1 girl. So in the table you can see that there are 814 families who are having 1 girl. So let F be the event that a family chosen at random is having 1 girl. Then probability of event F, that is P of F, is equal to 814 upon 1500, which is equal to 0.5427. Now the third thing which we have to find is a family chosen at random is having no girl. So in the table you can see that there are 211 families who are having no girl. So let G be the event that a family chosen at random is having no girl. The probability of event G is P of G is equal to 211 upon 1500, that is equal to 0.1406. Next question. An insurance company selected 2000 drivers at random in a particular city to find a relationship between age and accidents. The data obtained are given in the following table. Find the probabilities of following events for a driver chosen at random from the city. First one being 18 to 29 years of age and having exactly 3 accidents in 1 year. Second, being 30 to 50 years of age and having 1 or more accidents in 1 year. Third, having no accidents in 1 year. So here total number of drivers are 2000. Now first thing which we have to find is the probability of a driver being age of 18 to 29 years and having exactly 3 accidents in 1 year. So here in the table you can see that there are 61 drivers who are having 18 to 29 years of age and had 3 accidents. So probability of this event will be 61 by 2000, that is equal to 0.0305. Now second one, a driver being 30 to 50 years of age and having 1 or more accidents in a year. So here in the table you can see that for a driver being 30 to 50 years of age, we have to take the columns of 1, 2, 3 and over 3 accidents, because here it is given 1 or more accidents. So we have to add frequency of all the 4 columns except the column having 0 accidents. So it will be 125 plus 60 plus 22 plus 18, that is equal to 225. Now probability of a driver of 30 to 50 years of age and having 1 or more accidents is 225 by 2000, which is equal to 0.1125. Third one is having no accidents in 1 year. That is, we have to take the drivers of all the ages who had no accident in a year, because they have not mentioned the age over here. So the number of drivers having no accidents in 1 year will be 440 plus 505 plus 360, that is equal to 1305. So probability of driver having no accidents in 1 year is 1305 by 2000, that is equal to 0.653. Another question, 50 seeds were selected at random from each of 5 bags of seeds and were kept under sterilized conditions favorable to germination. After 20 days, the number of seeds which were germinated in each collection were counted and recorded as follows. What is the probability of germination of first one, more than 40 seeds in a bag, second, 49 seeds in a bag, third, more than 35 seeds in a bag. So, first of all, total number of bags are 5. Now, first one, number of bags in which more than 40 seeds germinated out of 50 is 3. From the table it is very clear. So, probability of the event of germination of more than 40 seeds in a bag is 3 upon 5, that is equal to 0.6. Second one, number of bags in which 49 seeds are germinated. Here in the table you can see that there are no bags in which 49 seeds are germinated. So, number of bags will be 0. So, probability of germination of 49 seeds in a bag is 0 by 5, that is equal to 0. Now, third one, number of bags in which more than 35 seeds are germinated. Now, here in the table you can see that in all the bags more than 35 seeds were germinated. So, number of bags in which more than 35 seeds germinated is equal to 5. So, the probability of germination of more than 35 seeds in a bag is 5 upon 5, that is equal to 1. Now students, let us see some of the exercise questions. Question number 4. 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. If 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. So here total number of times 3 coins are tossed is 200. Number of outcomes in which 2 heads are coming up is 72. So probability of getting 2 heads is 72 upon 200, which is equal to 9 by 25. So our required probability is 9 by 25, which means that if 3 coins are tossed again, then the probability of 2 heads coming up is 9 by 25. Question number 5. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and number of vehicles in a family. The information gathered is listed in the table below. Suppose a family is chosen. Find the probability that family chosen is first one, earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. Second, earning rupees 16,000 or more per month and owning exactly 1 vehicle. Third, earning less than 7,000 per month and does not own any vehicle. Fourth, earning rupees 13,000 to 16,000 per month and owning more than 2 vehicles. Fifth one, owning not more than 1 vehicle. So here total number of families is 2,400. Now in the first question we have to find number of families earning 10,000 to 13,000 per month and having 2 vehicles. So here in the table it is very clear that there are 29 such families. So probability of a family having earning 10,000 to 13,000 and having 2 vehicles is 29 by 2,400. Now students, it is not always necessary that you obtain the answer in the decimal form. You can keep it in the form of fraction also. Now second one, number of families earning 16,000 or more per month and having exactly 1 vehicle. So from the table you can see that there are 579 such families. So the probability of a family having earning 16,000 or more and having exactly 1 vehicle is 579 upon 2,400. Next is number of families having earning less than 7,000 and does not own any vehicle. So in the table it is clear that there are 10 such families. So the probability of a family having earning less than 7,000 and owning no vehicle is 10 by 2,400, that is equal to 1 by 240. Fourth one, number of families having earning 13,000 to 16,000 and having more than 2 vehicles. So in the table in the last column you can see that there are 25 such families. So probability of a family having earning 13,000 to 16,000 and having more than 2 vehicles is 25 by 2400, that is equal to 1 by 96. Now the last one is number of families having not more than one vehicle. Not more than one vehicle means either they are not having any vehicle or they are having only one vehicle. So from the table we have to add the frequencies of families having no vehicle plus the frequencies of families having one vehicle. So number of families having not more than one vehicle is equal to number of families having no vehicle plus number of families having one vehicle, that is equal to 10 plus 1 plus 2 plus 1 plus 160 plus 305 plus 535 plus 469 plus 579, that is equal to 14 plus 2148, that is equal to 2162. So, probability of a family having not more than one vehicle is 2162 upon 2400, that is equal to 1031 upon 1200. Next question, question number 7. To know the opinion of students about the subject statistics, a survey of 200 students was conducted. The data is recorded in the following table. Find the probability that a student chosen at random, first one likes statistics, second one does not like it. So, here total number of students whose opinion is taken is 200. Now, first we have to find the probability that a student chosen at random likes statistics. So, here in the table you can see that there are total 135 students who like statistics. So, probability of a student chosen at random who likes statistics is 135 by 200, that is equal to 27 by 40. Now we have to find the probability of the students who does not like this statistic. So here in the table you can see that there are 65 students who dislike statistic. So the number of students who dislike statistics is 65. So probability of a student chosen as random who dislikes statistics is 65 by 200, that is equal to 13 by 40. So students, these were some of the questions of your exercise. And with this we conclude our lecture as well as our chapter also. I hope that you have found out it interesting, and it is very small chapter, but it is the base for standard 10th, because same chapter is there in standard 10th but in much more detailed manner. So prepare it well.